Many of you may have already heard of Schrödinger's cat, but have you ever wondered how it actually works? In this video, you will be put in the shoes of Walther Gerlach, taking on one of the greatest minds of the century, and tasked to come up with an explanation for the counterintuitiveness of quantum mechanics. You have just released a seminal paper that outlines a revolutionary theory. The paper states that quantum mechanics requires that an object can be in two different states at the same time. Your paper also highlights many experimental results to support this theory and provides a simple example. Imagine we place a quantum ball in a bag. Without looking in the bag, we pull out the ball. Half the time, the ball is red and the other half the ball is blue. The state of the ball inside the bag must be both red and blue. Not one purple ball, but a ball that is simultaneously both red and blue. The ball remains in this state until we take it out of the bag and observe it. The paper takes the science world by storm, and gains much praise, along with much critique. On the other side of the country, your theory faces the monumental challenge of the mind of Schrödinger. He releases a counterexample to your now infamous notions. Imagine we place a cat, a deck of cards and a special device inside a box. The device activates when the cat touches any card. If the cat touches an ace, the device releases a deadly poison, immediately killing the cat. If the cat touches any other card, the device destroys the poison and the cat is safe. Schrödinger argues that, based on your theory, the cat is in a state of being both alive and dead while inside the box. How would you describe the state of the cat then? This thought experiment, given the moniker, Schrödinger's cat, seems to dismantle your theory. You begin to ponder the implications of this thought experiment. There are no tools in the existing physical theories to help you. In all of physics, an object is either red or blue, but never both at the same time. With your back to the wall and all your years of hard work at the risk of being undone, you gain one last insight. In quantum mechanics, the universe does not play by any of the existing rules. So why should you? This one insight allows you to level the playing field. If the physics to describe Schrödinger's cat does not exist, then you will create it. You start off at the simplest point possible. If the cat is both alive and dead, then the equation that describes its state should reflect that. You also stipulate that observing the cat is, in effect, the same as asking a question: is the cat alive, or is it dead? The universe provides the answer and chooses one of the two states as soon as the cat is observed. You had come up with a solution to the cat paradox in the form of a self-consistent theory. In doing so, you had inadvertently come across a much more startling and fundamental truth. The universe operates on a set of rules. The aim of quantum mechanics is to simply figure out what those rules are. The answers to this hold the key to the most fundamental questions of the universe. The answers hold an equation for everything. We have just discovered rule number 1, the state of a quantum mechanical system, and all the information we know about it, can be represented by an equation. The ball is either red or blue. The equation simply describes the probability the ball will be red and the probability the ball will be blue when we pull it out of the bag. You walk out into your garden and watch the sunset. You had finally put all doubts to rest and successfully pushed forward in the journey towards truth. No sooner had you finally breathed a sign of relief that you were accosted by a postman with an urgent marked letter. It was from your partner, Otto Stern, who had worked on the experiments and theory with you. He states that he had received word of two physicists that were challenging the theory the two of you had created. Otto had enclosed pictures of these physicists inside the envelope. You shake your head and smile. If you had managed to contest the great Schrödinger, surely two young physicists were no challenge. The situation amuses you. Until you look at the pictures.